for the magnetic force. So we'll remember that magnetic force, FB, is equal to charge times V cross B. That's how we can use our cross product. Or if we wanted to find magnitude, we can find the magnitude of the force as Q times V times B times sine of the angle between V and B, and we can use our right-hand rule, which applies to positive charges. On this set of examples, let's find the direction of all the magnetic fields. Let's use our right-hand rule first, and then we'll use our cross product just to verify our answer. If you started asking the question that we get a lot of the times is, do I have to use my right hand? My short answer, well, two short answers. First, short answer is yes, you have to use your right hand. The second is, if you're more comfortable with the left hand or another format of this, as long as you understand it and you can apply it correctly, of course you can use your left hand. But I would recommend you switch to a right-hand rule because that's just most commonly used from now on in industry and university. Okay, so you don't have to, but I recommend it. So let's start by showing our coordinate system. X, positive X to the right, positive Y up, Z out of the page. That follows a right-hand rule as well. So out of the page will be directly towards you. Positive X is to the right, positive Y is up towards the top of the page. When we do our right-hand rule, your thumb goes in the direction of the first vector, so thumb goes with V. Your index finger goes in the direction of the second vector, thumb goes with B, and then your middle finger shows your resultant, your magnetic force. So we'll do this to find our right-hand rules. You should 100% be doing this along with me, and in fact I recommend that before I say the answer, you pause the video, you figure out the answer for yourself, then you come back and check it. Okay, example 1. We have a positive charge moving to the right in a magnetic field that points up. So we'll put our thumb with V, our index finger with B, and we see that our middle finger, the force, points out of the page or towards you. So there's the direction of the magnetic force this way, out of the page. Let's verify that with the right-hand rule. So for example 1, the direction of the magnetic force is going to be the charge Q, it's positive, so it's going to be plus the direction of V, which is to the right, that's I hat, crossed with the direction of B, which is up, that's J hat. So I cross J, you might remember what that is, or you might like to use our little triangle tool to remember it. If you do I, J, and K in a triangle, point from one to the other. As you go with the arrows around the circle, you get positive results. As you go against the arrows, you get negative results. So I cross J is with the arrows. Your answer is plus K, which is the same as out of page. Okay, there's number 1 done. Let's go on to number 2. Number 2, we have a negative charge. V is to the right, that's our thumb. B is our magnetic field, that's up. Our index, our middle finger is our magnetic field, that's coming out of the page, but that would be if our charge were positive. This is a negative charge, so we have to rotate it by 180, we get into the page. Into the page has a notation of an X, like we're looking at the flights of an arrow. Okay, let's back that up with our equation. So the direction of the magnetic force is going to be negative for our negative charge. V, which is I hat, because it's to the right in the positive X, crossed with B, which is in positive Y, or J hat, so we get negative I cross J is K, we get negative K, which is the same as into the page. Okay, that's number 2 done. Let's do number 3 next. Number 3, V is shown by the X, that's into the page, that's going to be negative Z. B is to the left, so that's negative X, and we have a negative charge. So let's use our right-hand rule. V goes into the page. Okay, my wrist is starting to get a little bit wonky. So into the page, and then still turn a little bit more. Into the page, your finger goes with B, and if I could properly turn, I would get this finger, my middle finger going towards the top. Okay, I kind of got it now. So this shows that my direction of the magnetic force is in the positive Y, but my right-hand rule is for a positive charge. This charge is negative, so my answer must be towards the bottom of the page, or down, or in the negative Y direction. So I'll draw that one in here. I didn't label my FB up here. Get that label in. Okay, let's see, does our math back this up? Example number 3, direction of our magnetic force is negative. Direction of V into the page, which is negative K hat, crossed with direction of B, negative X direction, so negative I hat. That negative and that negative gives us a positive, so we have minus K cross I. K cross I goes the right way around the circle, so K cross I gives us plus J, so our answer is minus J, which is the same thing as down. Okay, so our math totally backs up our answer here. Let's do example 4 next. Example 4, and remember you should be pausing every time we do this so that you get your own answer before I do mine. We have B points, we have V points up, we have B points up, and hang on a second. Our hand doesn't do that very well. I can't have this one pointing up and this one pointing up. That tells us that the cross product is equal to 0. If those two guys are parallel, there is no magnetic force. So for example number 4 here, the direction of FB is a positive charge Q. V points up, that's plus J, crossed with B points up, equals plus J. So the magnetic force here is 0. Last one is example 5. Let's see what we have for this guy. We didn't write it down. The sign of the charge in this one is positive. So we have a positive charge moving up and to the right in a magnetic field that points straight up. Let's get the direction of the magnetic field. So V points like this, that's our thumb. B points up, little angle between those two guys, but we can still do it. And then our magnetic force comes out of the page. The magnetic force has to be perpendicular to both of them, and that answer is out of the page. So we can draw that in here. Out of the page is the dot with the circle around it. And let's do our math to figure that out as well. Let's make sure we got it. So for our magnetic force this time, we have the plus for our sign of our charge, the direction of V. Well, V has two components to its direction. It has an I component and a J component. So the directions are partly I and partly J. That's going to be crossed with the direction of B, which is J. So for this part, we have 2 bits. So if we want to multiply this out with the distributive property, this gives us I cross J plus J cross J. Put brackets around those so we can see it a little better. I cross J goes the right way around the circle, gives us K hat, plus J cross J, which is 0, gives us K hat. So the direction, according to the math and the right-hand rule, is out of the page. Okay, in the next part, we'll get on to an example with some numbers.